Let us look at the validity of a Freundlich isotherm, students. See here, to understand this, we should look at this x by m is equal to k into p raised to 1 by n. Well, this implies that this is, if you plot a graph of x by m versus pressure, it means that we get this type of graph. What we notice, if pressure is increased, x by m is also increasing, and after reaching a particular value of pressure, what we notice is this extent of adsorption is appearing to be constant. See students, this implies that at high pressure, at certain high pressure, extent of adsorption is independent of pressure. This is the conclusion that we get out of this. And one more thing is, see students, here from here to here up to this range, the extent of adsorption follows first order kinetics. That means at low pressure up to this, we call it as equilibrium pressure. Up to equilibrium pressure, this extent of adsorption follows first order reaction. This is very much important. First order reaction. Then after equilibrium pressure, see here, after equilibrium pressure, here it is the behavior of zero order reaction, because no matter how much is the quantity of the reactants, but rate is independent of the quantity of the reactants. That means here extent of adsorption is independent of pressure. That means here n is equal to 0. That means x by m, extent of adsorption, follows zero order reaction. These are very much important points. Initially, adsorption follows first order kinetics, and after the equilibrium pressure, it follows zero order kinetics. Clear, students? Okay. Now let us look at this equation. We apply logarithm on both sides. See what we get. Log of x by m is equal to log of k into p raised to 1 by m. This is log of ab. This can be written as log of k plus log of p raised to 1 by n. And this is log of a raised to m. This can be written as log of k plus 1 by n into log of p. Well, this will be equal to log of x by m. Well, this is the logarithmic form of Freundlich adsorption isotherm. This is variable. See students, this is variable. Pressure is variable. This is constant, and this is slope. That means if you plot a graph of log of x by m versus log p, you will get a straight line whose slope will be 1 by m, that is positive slope, and intercept on the y-axis will be k. Let us draw that in. See here. This is log of x by m. This is log of p. Then this will be the straight line with the intercept of log k, and the slope will be 1 by n. See students, it can be extended like this one continuously. Now what we notice is, according to Freundlich, this 1 by n value, 1 by n value can be between 0 and 1. This is predicted. This is predicted. But found is 0.1 to 0.5. This you remember in students. Found is this. 1 by n can be, its value can be between 0 and 1, but found is 1 by n value is found between 0.1 to 0.5. Okay. Now we'll use these values and verify this equation. See students here. One thing is, upon reaching equilibrium pressure, extent of adsorption is constant. Clear? It means that upon reaching equilibrium pressure, extent of adsorption is becoming independent of pressure. Clear students? But here what we will notice, as pressure increases, x by m value will also increase. This may be the drawback. Let us say this. Okay. Let's go for first case when 1 by n is 1. This implies that, see students, either you put this condition in this equation or in this equation, makes no difference, you will get the same conclusion. Let us use this equation. See here, when 1 by n is 1, 1 by n is 1, it means that log p into 1. This means that log of x by m is equal to log of k plus log of p. Clear students? This 1 by n is 1. Then remove logarithm. Then what we get? This can also recognize x by m is k plus k into p. Or this implies that x by m is directly proportional to pressure. What does this mean? When 1 by n is 1, x by m is directly proportional to pressure. It means that this equation is capable of explaining this behavior up to this stage. It explains. As pressure increases, x by m also increases. That means as log p increases, log of x by m also increases. This is correct. It holds good enough. Correct. But look at the second condition. When 1 by n is 0. And this implies that, see students, this implies that this will be 0. That means this term will be 0. That means log of x by m will be log of k. This implies that log of x by m will be equal to log of k. Or this implies that x by m is constant. See students. When 1 by n is equal to 0, it means that extent of adsorption is constant. It means that even though increase the pressure, extent of adsorption is remaining constant. It means that at high pressure, that means when 1 by n is equal to 0, that is higher value. At high pressure, extent of adsorption is independent of pressure. But the problem is, this equation is not able to explain this behavior because it is continuously increasing. And hence, what we can say is, this part is the drawback. This equation cannot explain the independent behavior of extent of adsorption at high pressure. It means that this equation fails at high pressure, but holds good. That means correctly explains, holds good. It means correctly explains at low pressure values. Clear students?